I'm Austin Manel. This is my complex circuit. What it does is basically controls the speed and direction of these two motors here, and I can do that by using NPN and PNP bipolar transistors, and this just allows me to switch the polarity of these motors as well as to control the speed by using pulse width modulation on the base of the transistors. So a transistor basically is, or in my case, it's a switch, an electronic switch. So when I apply 5 volts from the digital pin of the Arduino to the base pin of the transistor in an NPN transistor, it allows current to flow from the collector to the emitter. And a PNP transistor, when a voltage is applied to the base, it does not allow current to flow from the collector to the emitter. When there's no voltage applied to the base, it allows current to flow. And the same thing with this one, when there's no voltage allowed at the base, it does not allow current to flow from the collector to the emitter. So it's the opposite. An NPN transistor is the opposite of a PNP transistor. And I'm basically using this in my circuit to control the polarity of these. So these two transistors control the backwards motion in my case of this motor, and these two transistors control the forward motion in my case of this motor, and then the same thing for these 4 for this motor. So for the backward motion of this motor, we can see that we have digital pin 11 going to the 47 ohm resistor going to the base of this NPN transistor, and then we have the digital pin 12 going right to the base pin of this PNP transistor, and that allows current to flow from the collector to the emitter. So if we go down here, we can see that the positive end of the 9-volt battery is connected to the collector end of this transistor, and then over here we can see that this goes down to this column right here, and then that goes to this side of the motor. And then for this one, we can see that it goes to the negative end of the 9-volt battery, and then the collector goes to the emitter goes to the negative end of the motor, and that allows current to flow when voltage is applied to the NPN, and when no voltage is applied to the PNP, it allows the motor to spin in a backwards motion. And for this one, it's the same exact thing, except the motors, the sides of the motors are switched. So this is connected to the negative end of the motor here, and then this one is connected to the positive end of the motor, which is here. If you follow my cursor, you can see that. And it's the same thing for this set of motors too. It just changes the polarity of the motors. If we take a look at the schematic over here, we can see a more in-depth representation of it. So all of the digital pins go to the base of the transistors, and if you follow the whole path, you can see that each of the collector and emitter go to either the motor or the battery to control the motors. So this circuit would be considered an exclusive OR logic gate, because if one of them is on and the other's off, it'll allow current to flow, and then if the other one's on and the other one's off, it'll allow current to flow. And that's why that's what an exclusive OR gate is. In fact, if they're both on or off, it'll create a short circuit, because it'll allow current to flow to the battery itself, which creates very low resistance and will discharge the battery at a fast rate, which can damage it. So this is my program explanation. So you can see in my sketch I have my circuit explanation, which I explain and then my program explanation, which I'm going to explain right now. So to start off, we have an integer state. State is just a variable for the mode that I'm in when I send my the radio frequencies over to the receiver. The different channels are the states which the integer represents. And then over here we have different motor outputs, and the numbers are just the pins which the transistors are in. So you could see NPN, PNP, all 8 of them, and the different motors in the different direction that they represent. If we scroll down more, we can see my vacuum pin, the transistor. Well, let me explain what I'm doing. I converted a iRobot Roomba into a controllable one. So I took away all the autonomous features and used my circuit to control the different motors. And yeah, and this is, I added a vacuum to it, which I already had. All I had to do is take the positive negative leads of the motor and hook them up to an NPN transistor so I could control the on and off features of the vacuum motor. And that's the pin that the NPN transistor base is in for that vacuum. Roll, pitch, and auxiliary are the channels that my remote controller for the Roomba is. So we have roll, which is the left and right movement of it, and I have that on a potentiometer on my transmitter or controller. And then pitch is the forward and backward movement, and that's pin 7. And auxiliary is just a switch for the vacuum, which is on my controller. And then we have the values of those different pins, which is from the receiver of the transmitter, and that's the value that outputs from the receiver, which is PWM, which we will see later. And then vac val is just the switch of the controller. And then roll val scaled and pitch val scaled, that's just the scaled value of the roll and pitch feature of left and right, forward and back. It just scales that down to make it easier, the numbers easier to work with, because the PWM values, which are the raw values coming from the receiver, aren't too nice to work with. And then these are these represent the different states that the gimbal is in, and the gimbal is just the roll and the pitch, and that's hooked up to potentiometers, which converts that into a PWM signal and then transmits it to the receiver, and then the receiver outputs the PWM signals, and that represents like which quadrant the gimbal is in. So you can see roll pause is when I move the gimbal to the right, and that gives a positive, or like, I guess you could say it adds to the PWM value. And then pitch val pause is when I put it in forward motion, and that increases the PWM value. And then you obviously roll val neg is the negative, so if I move the stick left, it goes negative. And then pitch val neg is backwards, and that decreases the PWM value. And then down here we have some simple stuff. The serial begin, that begins the serial monitor. It starts communication with the board. And then we initialize all of the pins of the transistors, including the vacuum pin, and we set those as outputs. And then we initially set state equal to 0, and 0 represents the neutral when the gimbal is in the middle, which makes the Roomba not move at all, doesn't activate any motors. And then we set the outputs, the pins coming from the receiver of the controller, we set those to inputs to the Arduino. And so if we go down to the loop, we can see that roll val is equal to pulse in of roll input. Roll is just the pin which is coming from the receiver, and then pulse in is a function that reads the PWM value of the receiver, and then that's equal to roll val. And then same thing with the pitch and the switch. The switch is easy because it's just two values of the 2-position switch. It's easy enough to just use that, and you can see that down here. And then that's the PWM value, and then the digital write and sets that to high when the switch is high, and then it prints vacuum is on, and I have space between the different values. And that is just for the printing, the serial print, just to space the different comments out. And then we have an otherwise statement, or else, and then if that is not greater than this PWM value, it sets the vacuum pin to low, which means the NPN doesn't allow current to flow, which turns the motor off for the vacuum. And then what this is right here is that when I move the gimbals on the transmitter, the receiver sends out a PWM value that is has an offset, so it doesn't start at 0. It starts at this number for roll and this number for pitch, and that just allows the least amount of latency when you're moving the controller different directions. So the PWM value has a lot of very little latency when you move it, and that just subtracts it, so it starts off at 0. And then this is just the pitch value minus the offset. That's just doing the same thing as this one. Then there's the roll, the scaled roll value is, and then this is just bringing those big values, the range of the gimbal movement of like the PWM output from the receiver, and then that just scales that down between 0 and 255, which is the PWM value for the Arduino, which I'll explain more later. And then we scroll down. So this part, all it's doing is making it so, because sometimes the values could jump over the maximum that the Arduino could take, and that's not good. So what we do is, when that's over the certain value or under the certain value, we just make it the maximum that could be, or the minimum down here. Yeah. And then down here, so this part right here, that's roll scaled is more than 100 and less than, more than negative 100 and less than 100. That's like the neutral zone, and the same thing for the pitch stick. And then that just makes it equal to 0, which is also the neutral state. And then for this one, when the roll scaled is neutral, but the pitch value is more than 100, that's the forward state. And then for this one, same thing, but when it's less than negative 100, that's the backward statement, so state equals 2. And then this one, when roll is less than 100, which means it's the stick is to the left and the pitch value is neutral, make it state equal to 3, which is the left state. And then this one is just the opposite. When it's more than 100, state is 4, which is the right state. And this whole section here, all it's doing is making the negative values and negative values of the scaled and positive values of the scaled separate. So when it's more than 0, that value is equal to the positive roll value, which we talked about earlier. And then otherwise, the value is equal to 0 when roll scaled value is less than 0. And then for this one, it's just doing the opposite. When it's less than 0, the negative roll value is equal to additive inverse of the scaled roll value. And then, because that's when it's negative, when the scaled roll value is negative 255, it makes the negative roll value 255, because that's what differentiates the positive and negative roll values. Because when we send those values to the transistors, it only reads between 0 and 255, which the Arduino processes as a PWM signal. Then otherwise, if it's more than 0, set the negative roll value equal to 0. And then this is just doing the same thing for the pitch axis. And then we start with our motor outputs. So when state is equal to 0, we print neutral on the serial monitor, which is what it is right now, and then we write NPN as low, which means that blocks current, and then PNP as high, and that blocks current too. So we do that for all the NPN and PNP, so it blocks all of the current for all of them, so no current is flowing in the circuit that's coming from the battery that's powering the motors. And then that's state 0. And for state 1, which is forward, we do an analog write to the digital pin, which means it sends out PWM values, which I was talking about, which is the pitch value positive, or the positive pitch value, which is between 0 and 255, which is when we move the pitch stick forward. So it sends a PWM signal to the base of the transistors, so you can control the speed of the motor just by modulating the on and off of the voltage going to the base pin of the transistor, and that allows you to control the speed of when you're going forward. And then you can see that the backwards motion is it blocks current, and then the same thing for the motor 2. It allows current to flow, and it varies the speed because it sends it in PWM values. And then this blocks current because we don't want it to go backwards. And then this is just the same thing, but with the negative pitch value, and then that you can vary the speed when you're going backwards. And you can see the forwards motion blocks current for both of them, here and here. And then when you're going left and right, I didn't put any variable speed because you really don't need variable speed when you're just spinning the Roomba. And then we just all we do is set motor 1 forward and set motor 2 backwards, because it twists the Roomba around so you can turn it. And then this is just the opposite of that. It sets motor 1 backwards and sets motor 2 forwards. And that's the extent of the code. I know it's a lot, but it's pretty simple if you think about it. So now I'll show you when I move the stick of the transmitter. So if I move, right now it's in neutral, so you can see the neutral state. If I move it forward, it goes into forward mode, back to neutral. And then if I go backwards, back to neutral. If I go left, neutral, right, neutral, and then I can flick the switch and it'll say vacuum on and in neutral mode. There's some little bugs that allow it to change the value. Vacuum off and it stays in neutral. So this is the Roomba using the circuit and an Arduino Mega. I'm using an orange RX receiver with a Spectrum DX7 transmitter. I'm also using a 4-cell lithium polymer battery to power the motors, and a 9-volt battery to power the Arduino. And this just uses a 2 geared DC motors to control the wheels, and it's made with a just one motor for the vacuum which is geared to both of these spinners. And our front pivot wheel, not powered, just a swivel wheel to be there. And we have a mess to clean. So you can see I can turn left, I can turn right. It's pretty slow, but it's effective. Left, right, forward, backwards, and vacuum. So if we need to clean up this mess, you turn left, turn on the vacuum, and clean it up. It works.